This is the second video for section 2.5, and what we're going to be dealing with are cosecants and secants. Now, unfortunately, the examples only show cosecants, but realize the same process would be done for secants, just one minor change, and I will explain that when the time comes. Example number 4 asks us to graph y equals the negative cosecant of x. Now, the first thing we need to realize is that the cosecant is the reciprocal of sine, and so the easiest way to graph cosecant and secant are to first off graph the appropriate sine or cosine. In this case, we're going to be dealing with sine. So I'm going to pretend a little bit that this is actually saying negative sine of x. And I'm going to do the same graph that I would if I were doing negative sine of x. Well, negative sine of x, the only thing I really have to worry about is the negative. This negative is not directly affecting the x, which means all I'm going to do is to reflect it over the x-axis. And we'll think about that when the time comes to actually doing the graph. But once again, I'm interested in the negative sine of x, which is the reciprocal of cosecant. I know the boundaries are a positive 1 and a negative 1, and the period's not going to change any, except I do want to change this a little bit. Normally I'd put the period of 2 pi over here, but instead I'm going to put it at the second mark instead. And so that will become 2 pi, this will become 4 pi, and back here will become negative 2 pi. And then if I were to graph it, sine, I know, starts here at 0, 0, and the negative does not affect that. Where the negative comes into play is that rather than going up to the top, the first one, the negative says we have to reflect that over the x-axis, and so we're going to start down, but then from then on it's going to be pretty simple. We do need to be very careful though, and I made a pretty huge mistake here, in that every period has to have 4 marks. So if I don't put those 4 marks in, then we will get some wrong answers here. So at the first mark, it's going to go to the negative, 0, positive, 0, negative, 0, positive, 0, negative. And then this one, since it's actually going to be coming around like this, that means it goes positive, 0, negative, 0, and it would continue forever and ever in that general direction. Okay, now this would be the sine curve if I would actually draw it. I'm not going to do that, but realize if I would draw a nice smooth curve going through this like this, we'd have a nice beautiful sine. Actually, it'd be the negative sine of x. It'd continue on forever. But I'm interested in what's the negative cosecant of x. Well, I've done the hard part. I found some points. Now, any place it crosses the axis here, those become asymptotes. That's the first thing to do. So we've got several periods going on here, but that's okay. We're actually almost done. And realize the next one would be right here. Okay. So now what happens with the secant and the cosine both, or cosecant I mean, is that from these endpoints we're going to draw what appear to be parabolas, but they really aren't parabolas. But they certainly appear to be that way. And every other one will be going up, every other one will be going down. So we get something that looks like this. Now realize my particular example, or at least my graph, was a little bit of overkill, but that's perfectly fine. This is a pretty standard You know, this is the negative cosecant of x, as best as I can do it. The only difference between cosecant and secant is the fact instead of using the beginning of sine, like we did here, we would draw the corresponding cosine and then go from there. But the same rules would still apply. Wherever it crossed the 0, we would make that the asymptotes, and it would go from there. And then we would have both extremes, tops and bottoms, and it would give us, in essence, the exact same shape. It would just be shifted or squished or something like that. It would appear just slightly different. And the final example for this section is number 5. Y equals 2 cosecant of 6x. Okay, now we are back to sines and cosines, so we do have to remember that the period of sines and cosines are 2 pi. This time, instead of doing 2 periods over here, I'm just going to do 1. So we're going to revert back to the 4 marks representing the entire period. And we need to look at a couple things here. Cosecant, well, that's the reciprocal of sine. So I'm going to initially think about sine. And in sine, I know this would represent an amplitude of 2. So that means it's going to go from a -2 to a +2. And this affects the period. The period would be determined as 2 pi over 6, or would be pi over 3. So I'm going to put pi over 3 here on the 4th mark. And so sine starts at 0, 0. There's no shift up or down. Realize the shifts would be handled in exactly the same way. And since there's no negative, that means the very next one's going to be up. And so we're going to go up to the top, to 0, to the bottom, and to 0. Now since this was on its way down, this one's going to go to the bottom and to 0. And the same rule applies. Every place that it crosses the 0 line, that becomes an asymptote. So there's my asymptotes. And I'm going to pretend that there's a nice little graph going along like this. All I need to realize is these are the important points. From this point, we're going to draw what appears to be a parabola. But it's not a parabola because it doesn't always forever go out. It's never going to reach the asymptotes here. And so we're going to get something that looks like that, and then like that, and realize this would go on forever and ever as necessary, but you'll never cross these asymptotes. That's the big, huge thing you need to really be concerned about.